Yo, what's up, Algebra 2 Trig people? It's Paul here, touching base with a video for the first topic for this week. Now, this topic is something that you're probably somewhat familiar with. We're not trying to introduce something crazy and new, and we're not trying to throw anything away. We're just here to talk about distribution. But to be a little bit more specific with it, maybe than what you've done in the past, we're going to be looking at distribution of multiplication over addition and subtraction. Just to be clear, this is the kind of distribution that you're probably used to. I'm specifying this because we might look at some distribution that you're not super used to later on in the week. Just a quick reminder, if you don't have your notebook and a pen or a pencil or something, you should go get that right now because these are notes. You should be taking notes. You're going to use these notes later on to do things. So if you haven't grabbed it yet, hit the pause button, boop, and then come on back. Welcome back. I'm glad you have your notebook. So let's look really quickly at what we mean when we say distribution of multiplication across addition or subtraction. Here's an example of an expression that you could use multiplication, or you could use distribution to simplify, right? Now notice here we have this 6 on the outside, and there's a 10 minus 7 on the inside. And what most people would say is like, oh yeah, you're going to distribute the 6. I mean, I would probably say that if I were talking to people, like I'm talking to you right now. But we want to be a little bit careful because we're not really distributing the 6. Because note, there is a multiplication symbol right here between the 6 and the 10, even if we don't write it. So really, what we're doing is we're distributing these 6 times. And that's important because we don't distribute numbers. We distribute numbers with operations, okay? So I'm going to try to be better about saying distribute the 6 times or the whatever times. And we're going to try to hold you to that same standard, even though it is tricky. How do we simplify this expression using distribution? Well, we would start, right, with this 6 times the quantity 10 minus 7. Often with distribution, we like to show that we're distributing by kind of using arrows or lines or things. So we would do the 6 times both of those parts. We would then get 6 times 7 minus, or 6 times 10 minus 6 times 7. Notice, right, that like the subtraction symbol doesn't change in this situation, right? Um, we then would simplify that to 60 minus 42, giving us a final value of 18. Cool. Now, this is nothing crazy, right? You've done this before. But how do we know if we're right? How do we know if we made a mistake or not? Well, this is one of the great things that occurs sometimes in math. You can often do things more than one way. And so what we also want to look at is how you would simplify this, not with distribution, but with the steps of operations. Just simplifying, working our way inside out, just like we would do in some of last week's practice. So when I look at this scenario here, this expression, what I see is, oh, I have parentheses right here. So I'm going to start by just simplifying everything inside the parentheses. So 10 minus 7 is 3. This is 6 times 3. And now we have a single term inside the parentheses, so we're not going to actually be distributing. This is just 6 times 3, which is 18. So notice that we got 18 over here using distribution. We got 18 right here using sets of operations. That is a great thing to have happen in math because it really makes it very likely that we're correct. And that, just so y'all know, that's a math fact. That's a math fact, okay? Hashtag math facts. So that's an example. That's kind of what you're going to be practicing. You're going to be simplifying both ways, using distribution and using the sets of operations. Just a heads up, you might have an expression like this, 3 times 2x plus 4, which if we wanted to simplify that using distribution, we can do that as well. We have our 3 times 2x plus 4. We put in our little arrow people. That gives us 3 times 2x plus 3 times 4, which simplifies to 6x plus 12. Boom, we're done. What about doing this with the steps of operations? I'm going to go out on a limb and just say, nope, can't do that. And maybe that's a question for you. Why can't we actually simplify this expression right over here with the sets of operations? Something to think about. So distribution is useful. Distribution of multiplication across addition and subtraction is definitely something that's worth having kind of in our toolbox of math. And that's that. Good luck with the practice. If you have any questions, hit us up. Hopefully you took the best notes ever. And this video, right, you'll have access to it if you need to refresh yourself. I don't know. That's all I got. That's all I got. Bye.